Hi everyone, this is Dr. Rich and I want to talk about stroke volume. So we've got many factors that affect stroke volume. I specifically want to cover preload, contractility, and afterload, since these are three pretty confusing topics. So remember, cardiac output equals stroke volume times heart rate. At an increase in stroke volume will increase cardiac output. So what we know is that preload, by definition, is the amount of stretch on the ventricles at the end of atrial systole, or better, at the start of ventricular systole. So preload is really proportional to venous return, and when we increase venous return, we increase end diastolic volume, and we're going to increase preload. All that means is the heart muscle is stretched more, and when you stretch it more, it contracts harder. So preload is really determined by venous return, and that is reflected by end diastolic volume. The second thing we need to consider is contractility, or how vigorously a cardiac myocyte contracts for a given preload. So if preload does not change, if venous return does not change, and if end diastolic volume does not change, we can change the strength of contraction of a heart cell, of a cardiac myocyte, by chemicals. And I'm talking about neurotransmitters. Those are norepinephrine or epinephrine, released by the sympathetic nervous system. Contractility can be decreased by acetylcholine, which is released by the parasympathetic nervous system. So the sympathetic nervous system increases contractility. The parasympathetic nervous system decreases contractility. And both of those will influence end systolic volume. So if we increase contractility, if we really increase the amount of calcium in a cardiac myocyte for a given amount of stretch, we will decrease end systolic volume. That ventricle, that left ventricle, will squeeze more vigorously and it will eject more blood. Last but not least is afterload. Afterload is fairly complicated. I like to think of afterload as controlled by blood pressure. And afterload really is the force that the ventricles, the left or the right ventricle, pump against. So when afterload increases, stroke volume decreases. When afterload increases, we're going to increase end systolic volume. And remember, stroke volume is equal to end diastolic volume minus end systolic volume. So I can tell you these are really important concepts, and you'll be tested on them. You should really look up and be comfortable with the definition of preload, afterload, and contractility. And you absolutely must know what EDV is, or end diastolic volume, is, ESV, or end systolic volume, and finally know that stroke volume is equal to EDV minus ESV, and cardiac output equals heart rate times stroke volume. Okay, thanks everyone, and good luck.